So now we are back to our lesson. We are still in the same lesson. We are doing part C, radical functions. What does it mean, radical functions? How are we going to find its domain, its range? How are we going to find the vertical asymptote, the horizontal asymptote, all those things. Now, when I say radical functions, it means also it's a square root function. Uh, then, first of all, the radical function has the form radical of any expression inside. Guys, the expression inside could be degree 1 or degree 2 or even higher degree. But the maximum that you can see now, it's degree 1 or degree 2. To find the domain of any radical function, we know that under the radical, I cannot have a negative answer. But it could be 0 because radical 0 is 0. So what is the domain of a radical function? Under the radical should be bigger or equal than 0. So here, x should be bigger or equal than minus b over a. Now, how are we going to find the range? What I'm saying here is just steps to follow. But when I will do the example, you will get those steps so you understand what I mean by this. So I start from the radical bigger than 0 and then I link it to y. This one, what I wrote here, you will get it in the example. But just let me write it for you. So when you are reviewing, you see the steps so you understand what I mean by this. To find the vertical asymptote, I need to have a fraction first. And then the value that makes the denominator 0 is the vertical asymptote. Also, to have a horizontal asymptote, I need to have a fraction. I solve for x, and the denominator, the value that makes it 0, gives me the horizontal asymptote. All those are just rules. Let's do an application to understand what I'm saying here. We start with the first example. Find the domain and the range of the following function. I have y is equal to minus radical to x plus 3. Then verify your answer graphically, so we're going to draw it too. So as we said, to find the domain of a radical function, I need to take under the radical should be bigger or equal than 0, not strictly positive. Strictly positive, later on we'll see it when it's a fraction. So x should be bigger or equal than minus 3 over 2. How I can write the domain? I have two methods to write the domain. Either I can write it this way. I can write domain, it's x with x bigger or equal than minus 3 over 2. Or I can also write it as an interval, because when I say bigger or equal than minus 3 over 2, it means minus 3 over 2 plus infinity. So those two ways of writing of the domain are both right. But when I write it as an interval, I should write here equal, not 2 points. Be careful, equal. Now, the range, as I said, I start from the radical positive and I try to link it till y, and then I will find the range. What does it mean? This is the range, it means the value of y. Yes or no? Yeah. This is y, guys. All this expression is y. What I know about y, I'm 100% sure that what this radical is positive. So I know that radical to x plus 3 is bigger or equal than 0. What do I have before the radical here? Minus 1. So as I'm multiplying the both inequalities by the inequality, the both part of the inequality by minus 1. When you multiply or divide by minus 1, now here I did times minus 1. You need to, what will happen to the sign? You're going to switch it. So I will have minus radical 2 x plus 3 is less than or equal to 0. Excellent. What's still missing to reach to the expression of y plus 2? Here, this one, it's the same as if I write minus radical 2 x plus 3 plus 2. So I add plus 2 on both sides. When you add 2 on the both sides, nothing will happen. Why? Because it's like a scale here, like a scale. So now I add plus 2 on the both sides. So I will have the whites here less than or equal to what? To 2. What does it mean that the range is less than or equal to 2? It means all the time for any value of x that belongs to the domain of definition, the answer of the range, the answer of y cannot be other than less or equal to. It cannot be bigger than 2. How can I check this, what I did as a graph? You will see it in the graph. But before, look, I can write the range also either like this or like this. Now let's graph it. How do we graph it? I already did it here. But I know that the domain is bigger or equal than minus 3 over 2, and the range is y is less than or equal to 2. But before I want to check if this is right. Is it right that my domain is this and my range is this? So what I do? I will try to replace x by minus 3 over 2. So I try to take some particular points to see if is it right that this one, because when I say x bigger than minus over 2, it means the value of x should start from here and go more. And when I say y less than 2, it means the value of y should be less than this one, and it should start from here. So let's take a value. Let's take x equal minus 3 over 2. If you replace x by minus 3 over 2, 2 times minus 3 over 2 gives me minus 3. Minus 3 plus 3 is 0. Radical 0. So what is the answer? 2. It means minus 1.52. This is the first point here. Now I need to see, is it increasing or decreasing, because the radical all the time has this shape or the other shape. So I take another point. I choose for x0. For x0, it gives me 2 minus radical 3. It's approximately 0.26. So it's here. Now, if I join those two, the radical will continue like this, and this is the graph. So I can check then, yeah, right, my domain is right, because here it's minus 3 over 2. So all the value of x are greater than minus 3 over 2. So I'm right with the, sorry, I'm okay with the domain. The range, it's here, and all the values are less than minus 2 or equal, it's true. So what I did before in the domain and range is right. Let's do one more example. Find the domain and range of the function, state the asymptotes, then graph it. Again, domain of definition. Here, I have a fraction and a radical. We did already in the preceding video that when I have a fractional expression, the denominator cannot be equal to 0. But here also there is a radical. It means this radical under the radical is strictly positive. I cannot have it equal to 0. So x should be bigger than minus 1. I can write the domain this way or the other. I just wrote it here like this. How are we going to find the range? If I solve for x, or if I, so I will have, I can say radical x plus 1 is equal 1 over y. Or what are the possible value of y? Y is equal 1 over 1 is positive, and radical x plus 1 is positive. So first, I'm sure that y is positive, bigger than 0. Can y be 0? It cannot be equal to 0, because in the numerator, I have a constant. And we know that a fraction is equal to 0 if the numerator is equal to 0. The numerator cannot be equal to 0. It means y cannot be 0. So I'm 100% sure that for any value of x, my answer will be all the time positive, because plus over plus gives me a positive answer. So the range is y bigger than 0. Now, what does mean vertical asymptote? The vertical asymptote we said we found from the denominator not equal to 0, because I cannot have it as a value for x equal to minus 1. I cannot have an answer, but it's a vertical asymptote. And also, can I have y equal to 0? I cannot. It's impossible. So this is called a horizontal asymptote. Later on with the functions chapters, we will use the limits to find the asymptote. You will see it there. But it will be more complicated, because the function will be more complicated, not simple like this one. Now, how are we going to graph it to check what we did? First, we're going to we draw the vertical asymptote. Excellent, this is x equal minus 1. This is my horizontal asymptote. And all what we need to do is to take some points. If you take x equal to 0, if I take the point x equal to 0, it gives me y is equal 1. So this is one of the points. I know that this is my vertical, this is my horizontal, so it should go like this till here. So is it the domain here, the domain, the values of x? Is it all the values of x bigger than minus 1? Yeah. Is the range y bigger than 0? Yes. So what I did for the domain and the range is right, and I don't have any problem with that. This is for the radicals. We will do more application in the class. Hope you like the video. Don't forget, guys, to like, subscribe, and share, and follow me for more videos.